Okay, solving trigonometric equations with identities. What is an identity? What is an identity in trigonometry? Well, in trigonometry, an identity is an equation that is true for all allowable values of the variables involved. So all allowable values of the variables involved. What does that mean? Well, for example, think of the following. Suppose you have the unit circle, right? Think of this. This one here, the radius, right? And this, remember, is cosine. Let's consider this to be the angle theta, cosine of theta, sine of theta, right? And applying the theorem of Pythagoras in this triangle, you can quickly see that sine squared plus cosine squared is 1, right? And this is what we call the Pythagorean identity. True for any angle, right? Any value of theta will satisfy this. Sine of theta squared plus cosine of theta squared equal 1, right? Since this equation is true for any value of theta, then it is an identity. It is an identity, right? If you substitute theta here for 30 degrees, it will hold. If you substitute theta with 12 degrees, it will hold, right? You can always verify that in your calculator. So this is what mathematicians call identities. Also, if you take tangent of theta here in the unit circle, tangent of theta is opposite sine of theta over adjacent cosine, then you have another identity, it's called the quotient identity, right? These are examples of identities, equations that are true for any allowable value of the variable, right? Any allowable values of the variable, because sometimes you will deal with quotient. So for example, if you take theta here to be pi over 2, this will be 0. It's not an allowable value, right? Because it will lead you to undefined situation. But if the theta is reasonably taken, this should be true for any value of theta. So these are examples of identities. And we have the identities separated in three groups, right? Reciprocal identities, quotient identities, and Pythagorean identities, right? They're all identities. But turns out they are not the only ones out there. There are thousands of them. It is just that they are not in these three groups, okay? So your job now is to show if a given equation is an identity or not. Most of the time they will ask you to verify that it's an identity, okay? So we'll have that in the back of our minds, but how you do this, right? For example, here, look at this equation. Cosine of x multiplied by tangent of x plus sine of x equal twice sine of x. They are asking you to verify this identity, right? This identity is not in any of these three groups, right? Doesn't look like any of these three or any of the identities in these three groups, right? So we should verify that it's an identity. How? Well, here is a method that will allow you to do that. Method to verify an identity. Step 1, identify the complicated side between quotations and the simple side. The complicated side should be the one that looks longer or more complicated, right? The simple side should be the one that looks smaller, less complicated, right? So first, you're going to identify complicated side, simple side. Step 2, turn the complicated side into the simple side, okay? And following these two steps, you should be able to verify the identity. So let's apply these two steps to this example 1, right? To verify this identity. So first, let's identify the complicated side. In your opinion, guys, what should be the complicated side? The left side or the right side? The complicated side. left, Jay, right? Excellent. I'm with you, Jay, there, because the left side looks bigger, right? Looks like I can do some work here, right? The right side looks like something that I cannot work with, right? So definitely this one, complicated side, right? Complicated side, right? This one should be clearly the simple side, right? Simple side. Very good, simple side. And now step 2 says, after you identify complicated side, simple side, turn the complicated side into the simple side. For that, guys, notice I have placed a question mark here, right? They don't look identical yet, right? But they will eventually, right? But let's put a question mark there. All right, so now I'm going to work on the complicated side, right? Using these well-known identities, okay? The ones that have been checked already, the ones that mathematicians have classified here in three groups, right? Using those. All right, so first here, cosine of x, I can write it as cosine of x, but here next, tangent, right? Tangent, I can write it equivalently using this quotient identity, sine over cosine equal tangent, right? I can say, okay, this guy is gonna be sine of x over cosine of x. Just tangent, right? Plus sine of x. They still don't look exactly or identical yet, so let's keep the question mark there. But now, notice, this guy, cosine of x, and this guy, they cancel, right? What is left? Well, left just sine of x here, plus sine of x, equal, still question mark because they don't look identical yet, but they're going to soon. And now finally, look, sine of x plus sine of x, this is just twice sine of x, right? 2 sine of x. Notice that I have worked out the left side, the complicated side, the simple side stays the same till the end. But now you see that they are identical, right? They are identical. So then you put a check. Then we have verified this identity. This equation is indeed an identity, right? Because look, they lead to the same exact thing in the end. Okay. Very good, guys. So this is a nice technique. I hope you follow that when you go over your special assignment 3. And when you go over the worksheets, I will show you next. Here is another example. Verify this identity. Verify this identity. I'm gonna give you some time for you to work on this on your own, and then we will do it together. Hint, what will be the complicated side? What will be the simple side? What will be the complicated side? The left side or the right side? What do you think, guys? Mojina, excellent. You remember that. Great. Left, right? Left, the left one should be the complicated side. So for the solution of this, solution here, solution, we are gonna take for our complicated side, the left side, okay? Secant of x equal question mark 1 minus cosine of x. So this will be our complicated side. Yeah, great. Complicated side. And the other will be our simple side. Simple side. Yeah, work with that, guys. Yeah, verify this identity. And then I'm going to give an extra hint. Yeah, yeah, the hint, very good, the question, right? Try to do this. Try to divide this cosecant into this cosecant into this, and see what happens there. Yeah, divide cosecant into cotangent. When you divide cosecant into cosecant, that will be just 1, right? They will cancel. Yeah, let's do it together, okay? All right, so, and try to remember again, guys, this for your special assignment. So this will be cosecant of x divided by cosecant of x minus cotangent of x over cosecant of x, right? Here, question mark, remember the simple side, we keep it the same. It stays the same. Question mark, they don't look the same yet. Cosecant into cosecant is just 1, right? 1 minus cotangent over cosecant. But what is cotangent over cosecant? Cotangent from the quotient identities is the same as cosine over sine, right? Cosine over sine, quotient identity. So I'm gonna use that. Yeah, cotangent, sorry, is cosine of x over sine of x. Very good. And cosecant from the reciprocal identities, 1 over sine, right? 1 over sine. Here, cosecant, 1 over sine. 1 over sine. 1 over sine from our reciprocal identities, right? Try to memorize those identities up there, or in case you don't remember well, then write them down, have it next to you when you do your homework, when you take your exams, right? 1 minus cosine of x, this guy still, right? Still they don't look alike. But now, remember, when you divide by a fraction, what do? We multiply the fraction on the top by the reciprocal of the fraction on the bottom, which is this, right? That's cosine of x. Yeah, let's give us, ourselves some space here. Great. All right, now, if we continue, this will be 1 minus, canceling this sine and sine, 1 minus what? Cosine of x over 1, but cosine of x over 1 is just cosine of x, right? And that is equal to 1 minus cosine of x here, identical now, so check, right? Done, right? Yeah, I want to see all these steps, guys, on your special assignment 3 when they are asking you to verify the identities, right? So don't forget to write the steps, right? And then the check there, showing that these guys are indeed the same. Now, let me tell you this, guys. When it comes to verify identities, there is no just one strategy that you can follow, one method. There could be some other methods around. Some people prefer to work with complicated side and simple side at the same time. Be careful there, but if possible, some other people, when they see that the two sides look kind of equally complicated, they just choose randomly what should be the complicated side, what should be the simple side. That works too, right? Yeah, so, but follow this strategy. It's a good one, right? It will help you. It will help. Okay. All right. Now, guys, I think we should go over the worksheet, okay? And then again, remember this for your special assignment 3. I think on the other lecture also, we will practice more on verifying this identity. So, but let's see how this is going to be tested. So this will help us to simplify, right? Simplify. So for example, can you try this one, number 7? Make sure that this one is done. It says the expression 1 plus tangent squared divided by tangent squared is to be the left-hand side of an equation that is an identity. Which one of the following 4 expressions can be used as the right-hand side of the equation to complete the identity, right? Maybe I can show you this one and I'll ask you to do something else, right? They're saying this is the left-hand side of the identity, right? There's something else here, right? But what is that, they say, right? What should be written here? This probably could be the complicated side. What should be the simple side, right? Yeah. So one thing you can do is just work it out, right? Work it out. There are several ways to work this out. One way, perhaps, should be the following. Divide this tangent into this, right? Yeah, so 1 over tangent square of x plus tangent square of x over tangent square of x, right? This is clearly 1, right? Now, what is 1 over tangent square of x? Well, recall 1 over tangent from our reciprocal identities is right here on the side, right? Recall 1 over tangent of x gives us cotangent of x, right? Cotangent of x. This guy is a square. Well, if you square both sides of this, you can get that this square should be cotangent square, right? Because 1 square is 1. This is tangent square of x equal cotangent square of x. Okay, so this cotangent square of x. But can we simplify this further? What is cotangent square plus 1? Using the Pythagorean identities. Well, recall also from Pythagorean identities. Identities. Cotangent square of x. I see someone figure it out here. Jay, great, right? Cotangent square of x plus 1 is cosecant square of x. Excellent. So this cosecant square of x, right? So then this should be what they're looking for there, right? They cannot go farther there. So cosecant square of x. You follow, guys? This goes there, right? Follow? That was for number 7. Very good. All right, next, try to do another one here. Yeah, number 8. Can you try number 8? Looks good. Yeah, can you simplify that so that it completes an identity? And again, use the well-known identities, the reciprocal identities, the quotient identities, and the Pythagorean identities, right, to do this work. Yeah, the hint is simplify this, right? Simplify this, the sine of x over tangent of x. Hint, use the quotient identity for this guy. I see. All right, let me check. Jay, yeah, excellent, Jay. Yeah, very good, right? Not hard to see that this guy is just sine of x over tangent based on the quotient identity sine over cosine, right? And let me tell you this, guys, very often I would say substituting tangent with sine over cosine, cotangent with cosine over sine, it's a good strategy. This becomes sine of x times, remember, when you divide by a fraction, that is equivalent to multiply this guy by the reciprocal of this fraction on the denominator, right? The reciprocal of this cosine up here, sine down here. But then these two guys cancel, and this is just cosine of x. Excellent. Very good. Can you try now this one? There is a tricky one here, but I think you will handle it. Number 3. Number 3. Sine square of x plus tangent square of x plus cosine square of x. Try to do this simplify, right? Using the reciprocal identities, quotient identities, or Pythagorean identities. Mm-hmm. Hint here, recall from Pythagorean identities. Sine square of theta plus cosine square of theta equal. I see someone figured it out. Jay, very good. Excellent, excellent. Excellent. You got it. Yeah, look, notice sine square plus cosine square from the Pythagorean identity. This is just 1, right? 1 plus tangent square. But again, using the Pythagorean identities, we have the 1 plus tangent square of theta is equal to secant square of theta, right? So this should be just secant square of x, which is here. Excellent, excellent. Okay. Very good, guys. Very good. Now try this one. This one, I saw one with quotients here that you will need for your homework. Can you try this? Cosecant of x multiplied by cotangent of x, all divided by secant of x. Hint, recall secant of x is 1 over cosine of x, right? And cosecant of x, 1 over sine of x. You can use that for the reciprocal identities. And cotangent of x equal cosine of x over sine of x, right? If you memorize these identities, very good, because you can quickly simplify. But if not, you can look at the Pythagorean identity, which also are available for us in our unit circle sheet. I will show you now. Yeah, that's a good thing to say here, worth it. Look, this is a unit circle sheet, right? If you go on the bottom, you will see there the identity. You see it? Reciprocal identities, Pythagorean identities. Here, there's more, right? But this is coming up on the lectures in the future later, right? So, but for now, you can use this identity, right? They are on the unit circle sheet on the bottom. Okay. Yeah, let's see. Let me uncover the choices. So anybody figure this out, number 5? And remember, when you divide by a fraction, you multiply by the reciprocal of the fraction, right? Okay, let's do it together, okay? Here, I'm going to substitute secant for its equivalent using the reciprocal identity 1 over cosine of x. Cosecant, I will substitute it by its equivalent 1 over sine of x. Cotangent, I will substitute it by its equivalent using the quotient identity cosine of x over sine of x, right? Very good. Okay, but now I know that when you divide a fraction, or in general, when you divide by a fraction, you flip the fraction on the denominator and you multiply, right? You flip the fraction on the denominator and you multiply. So let's do that. And let's see what we get. All right, so we're gonna get 1 over sine of x times cosine of x over sine of x times the reciprocal of this is cosine of x over 1, right? Now look at this. Nothing cancels, right? Nothing to cancel, but look at this. Cosine of x times cosine of x, cosine is square of x, right? Sine of x times sine of x, sine is square of x. Interesting form. But now notice that this is just, and here comes the tricky part, cosine of x over sine of x, all that is squared, right? Because remember, exponents can be distributed over quotients. So doing some little backward thinking, from here you can get this. But what is cosine of x over sine of x? That is just cotangent. Cotangent of x, right? And finally, mathematicians write the square when they deal with the squares of trigonometric functions in the middle like this, right? Cotangent is square of x. And this should be our final answer. Tricky one, but it's still doable, right? So try to remember these guys for your homework. Very good, cotangent square. What about number 6? Let's try to finish with number 6 perhaps. Oh, if there is more time, we can do one more. Do this, guys. 1 minus cosine of x over sine of x. Hint, distribute the division here, right? Get it done that way. And use, of course, the identities, the reciprocal identities, the quotient identities, right? Yeah, here, hint, recall 1 over sine by the reciprocal identities is cosecant. And cosine over sine, someone figured this out, by the quotient identity, cotangent. Right? Very good, very good. Jay, excellent. Well, let me check. Number 6. Yeah, you have to fix it, right? You fix it. Yeah, it was very close though. Yeah, try to fix it. Now can see. Excellent. Now, very good. Jay, very good, guys. Remember, in mathematics, sometimes you may make mistakes first, but don't feel bad about it. This is the nature of this subject, right? Through trial and error, we get to master the topics. So very good. Excellent. 1 over sine into 1, right? Minus sine into cosine is this, right? But this guy, 1 over sine, I'm saying, is cosecant. This guy is cotangent, right? Cosecant of x minus cotangent of x. Cosecant of x minus cotangent of x, this one, right? Notice, guys, the choices are very close to each other, so be careful when you pick your answer. Very good, excellent. All right, let's do the last one here. I saw one with a triple product. This one, let's demystify this. Okay, let's try this together. What will be this? Can you try? It's quick, just recall. Tangent by the quotient identity sine of x over cosine of x, and cosecant of x by the reciprocal identity 1 over sine of x, right? Yeah, very good. Use this, figure this out. And let's finish that. Okay, guys, let's do it together. Here, cosine of x, tangent using the quotient identities, sine of x over cosine of x, and cosecant using the reciprocal identity. One of the reciprocal identities is 1 over sine, right? Now, notice this cosine cancels with this cosine, sine cancels with sine. 1 is the only thing left here. 1 here, 1 here, 1 times 1 times 1, just 1, right? Surprising result, a number, right? But it sometimes happens because everything cancels except for 1. Good.